Hello everybody, and welcome to the top of page 56 in the workbook. And in this video, we are continuing our discussion of this lemma about cosets from the previous page. So in this particular video, we're going to be discussing result number 4, which I've written at the top of the page so we don't have to keep flipping back and forth here. Let's read this statement together. It tells us that two cosets AH and BH are equal if and only if the condition A inverse B in H is satisfied. Okay, now instead of writing a full-blown proof here, I'd like to just talk about the general strategy of the proof, to write down the scratch work, and just to give you an idea of how we might structure the proof, and then you can maybe try to write the proof yourself. All right, so notice first that the result that we're looking at is an if and only if, so we kind of need to think about two different directions here in this case. Okay, and in the forward direction, we'd be starting with the assumption that AH equals BH and trying to get to the statement that A inverse B is in H. Okay, so I'm going to start with AH and BH being equal. Okay, I've reversed the order on you, but it doesn't really matter. We can write that equality in either order. Okay, and think about what this statement is saying. It's telling us that these two cosets are identical to each other. So anything that lives in one of the cosets has to live in the other one. Okay, and if you think about the coset on the left-hand side, one thing that lives in B times H is B times the identity element. Okay, because after all, H is a subgroup, and so it has to contain the identity element. Okay, but here's the thing. If B times E lives in the set on the left-hand side, it also has to live on the set on the right-hand side because those two sets are equal. That means that this BE has to be expressible as A times something that's in H, okay, which I'll just write as a little h. Okay, so if B times E equals A times H, notice that B times the identity element is just B, so we get B is equal to AH. Okay, but if you take that equation and multiply on the left by A inverse, here's what you get. A inverse times B equals A inverse times A is the identity. That's just going to give us H on the right-hand side. And notice that that H lives in our subgroup H. Okay, so if you take a look at that condition, okay, or what this argument would show, it gets us to the exact condition that we wanted. Okay, so if you were going to write a proof of the forward direction, these are the general steps you would follow. You just have to fill in some of the details that we left out. Okay, and what about the reverse direction? Okay, well there, we just clear away a little bit of clutter here. There we'd be starting over here with the assumption that A inverse B is in H, and seeing if we can work our way back to the fact that AH and BH are the same coset. Okay, so if we take that statement, the fact that A inverse B is in H just means that A inverse times B is equal to some element that's in H. I'm going to call it H prime. Okay, and you could go from that statement and notice that by multiplying both sides by A on the left-hand side, we would get B is equal to A times H prime. But A times H prime, that's A times some element of H. By definition, that's in the coset A times H. Okay, and now we have kind of an interesting situation because we've just demonstrated that this element B lives in the coset A times H. We already know that the element B lives in the coset B times H, and so we've just demonstrated that the two cosets overlap each other. Okay, they both contain the element B. Okay, so that intersection is not empty. But we just proved in number 3 that if two cosets have a non-empty overlap, then they have to be exactly the same coset. Okay, so AH has to equal BH by 3. And that's what we wanted. That gets us back to the first condition. Okay, so you might try just filling in the gaps here. This gives you a pretty good roadmap of how you would write a proof. You just need to kind of make the language a little bit more precise to turn it into a full proof.